All right, this is part 2 of lesson 6.5. I just want to go over this quick here again. We have to choose some possible solutions, and we have to make sure that we pick appropriate solutions. So let me highlight the area again. And if I could color inside the line, which I used to be able to do, then I would see that now my domain starts at 0 and only goes to 4 for my package of hot dogs. And my range starts at 0 and goes to 2.5 for my packages of hamburgers. So any whole numbers in here, in the shaded regions, are possible solutions. So I want to look at those. Like 1, and I'll put a dot at every possible solution. Right, there's a possible solution, there's a possible solution, there's a possible, 0, 0, of course, is possible. And that's a possibility. So I can just choose any of these dots. I'll just pick this one. We could have 2 packages of hot dogs and 1 package of hamburgers. And that would be 2 times 5 is 10 for those hot dogs, and 8 for those hamburgers, and that's a total of $18, which of course is less than $20. All right, so for a party, you can spend no more than $12 on nuts. Peanuts cost $2 per pound, cashews $4 per pound. What are 3 possible combinations of peanuts and cashews? So let X be the number of pounds of peanuts and Y be the number of pounds of cashews. You can pause here if you want to try it on your own. We're going to do a little different way of making our graph here. We're going to solve the inequality for Y, so we put it in slope-intercept form and then use the slope and the intercept to make the graph. So if we subtract 2x from both sides, or add negative 2x to both sides, then we can divide both sides by 4, and we end up with negative 1/2 x plus 3 in simplified form. And to graph that, we can use the y-intercept of 3, right there, and the slope of negative 1/2, which means I drop 1 for every 2. All right, and then we want a solid line because it's less than or equal to. And I really don't need my line to continue past because negative values just don't make sense here. I can shade my region under the line and above the x and the y-axis. So those are all my possible answers. And I can take any of those that are, and actually pounds of peanuts can be, that's a continuous function. So I can really pick any point within this region. Doesn't have to be right on integer values. It can be though. So 3 possible combinations. I could buy 2 pounds of peanuts. I'll just label it like this. And cashews. So I'm talking about this point right here. 2 pounds peanuts, 1 pound of cashews. I could do 4 pounds of peanuts and 1/2 pound of cashews. I could do something right on the line using exact amount of money I have to spend, where I could buy 2 pounds of peanuts and 2 pounds of cashews, and so on. And there's an infinite number of possibilities for this problem. All right. One thing you may have noticed when we are making these graphs is that every time we had a less than graph, it was shaded below the line, and every time we had a greater than, it was above the line. So let's just make a kind of a generic graph here. And if I'm above the line, I'm greater than. If I'm below, I'm less than. If it's a dotted line, it is less or greater than. Solid line is greater than or equal to or less than or equal to. So we can look at a graph like this and make the graph by finding the equation of the boundary line. And to do that, let's look at the slope and the y-intercept. The y-intercept is 3, and the slope is up 1 over 2, which is 1/2. So the boundary line is actually y equals 1/2 x plus 3. All right, now the inequality that is represented by this is, since it's below the line, that's shaded, that means we're going to have less than, and since it's a solid line, it's less than or equal to. So the inequality graph is y is less than or equal to 1/2 x plus 3. Sorry about that, Bill. All right. So you're writing an inequality from a graph. Boundary line is dashed, and then the slope 1/3, and y-intercept -2. The area above the line is shaded. What inequality should you write? So the boundary equation is, since the slope is 1/3, the y-intercept is -2. We would get that. Since it's above the line, we want greater than. And since the boundary line is dashed, we want just greater than for our symbol, which would be that one. So y is greater than 1/3 x minus 2. All right, lesson check. Graph y is less than 3/2 x plus 3. Do you shade above or below the boundary line? Explain. Less than, we have found that we're always going to be below the line. So, and that's because less than is below the boundary line. Do you shade above or below the line for y is less than 3/2 x? And I think we answered that question. All right, so that's the lesson. We'll see you tomorrow.